Now let's look at Lab 6, which is on aggregation and also database creation. So as usual, go ahead and enter your name and the date. So question 1 asks you to list the distinct states for suppliers, but without using distinct, use group by instead. So let's do that for customer. So we'll select the state province from customer, and then what we want to do is group by state province. So this is going to collapse all of the columns that come back where the state province matches. So let's go ahead and try it and see what we get. So we have each state appearing only once in the list. And that's going to be the same result as if we had said select distinct state province from customer. So you see we get the same results either time, but the difference is that with aggregation, there are other ways that you can collapse columns. So we'll see that later on. So find the average total price, minimum total price, and maximum total price. So once again, we're going to be aggregating based on invoices. So let's go ahead and look at stove repair. So here's everything in that table. So to find the average cost, minimum cost, and maximum cost, we basically want to just select the cost column and then aggregate using different functions. So if we just select cost, that would give us all of the cost values and nothing else. To collapse on cost, we can go average cost, and then minimum cost, and finally maximum cost. And I have to give these columns names because these are going to be values that are computed on the column. So there's the average cost, minimum cost, and maximum cost. And you'll notice the formatting is off because it's taking a number and averaging it, taking numbers and averaging them. So we also want to turn this into a currency value. Like so. And then we can do that for all of the fields. Like so. All right, so now everything is correctly formatted. So this question is asking us to list each type in the stove table along with the total number of stoves for that type. So instead, let's return a list of each state in the customer table along with a count of the number of customers in that state. So let's start by looking at the customer table again. And what we want to do is basically everybody who's in Oregon, we want to collapse all of these Oregon rows into one row. And so we're just going to list the state province. We're going to group by state province and collapse that down. And then we're also going to just count the number of rows. So we can basically either pick one of these columns that's different, or we can just say star. So let's select count star, and we'll also pull out the state province. We have to give this a name. And then we're going to pull it from the customer table. And that's the clause that does the magic as far as collapsing everything down. So we see the number of customers by state. We see that there are 7 in Oregon. And then write another query to list each unique combination of type inversion along with the total number of stoves for that combination. So let's list each distinct combination of city and state province along with the total number of customers from that combination. So once again, we're going to count the number of rows. And we'll list the city and the state province. From customer. But this time we're going to group by both state province and city. Doesn't matter which order you put them in. So now we see that most of these are ones, but we have 3 customers from New York, New York, 2 from Portland, Oregon, and that's about it. Okay, so this is asking for the total extended price value. So we're going to sum the values in this column from the invoice line item table broken down by invoice number. So for each invoice number, we want to collapse all of the rows with that invoice number down into a single row and then show the invoice number along with the sum of the extended price values for that column. So let's do something similar with the PO line item table. Start by looking at everything. And what we're going to want to do is for all of these PO numbers that are the same, so I want one row for 601, so I want to group by 601, group by 602, 604, and so on. And then I want to sum the extended prices for each invoice. So to group by FK PO number, and then I want to show the FK PO number as well as the sum of extended price. So I get one row back for each PO number, and then the value here is the sum of the extended price values for each of the rows that got collapsed into this one row. Okay, this one asks you to display invoice number and total number of parts for every invoice. So for every invoice means that we're going to want to have one row for each invoice number. And if you look at the invoice table, you'll see that it doesn't actually list the parts. That's because there's an intersection table for inv line item. So that's actually the table you want to use for this query. So you'll notice that some of these have parts and some of them have stoves, but what it wants is the total number of parts for every invoice. So to get just the part rows, we can say where FK part number not null. Maybe is not null. Hold on. Let's see if this works. Yeah, is not null. There. So now we have just the part numbers coming back. And what we want to do is group by the invoice number and then sum the quantity. So I'm not going to do that query, but I'll do something similar for the repair line. Let's try repair line item table. Select star from repair line item. It's either that one or the PO line item. Yeah, so this has quantity in it. So if we wanted to sum up the quantities and only show one line for each repair number, we would group by repair number. And then we could display the repair number as well as the sum of the extended price. Okay, and then to order by repair number, we just have an order by. And it works fine. So between this and what I just showed you, you should be able to get this query. Show the invoice number and total extended price. Use sum for every invoice in the invoice line item table, but omit invoices whose total extended price is less than 100, using the having. So here we've totaled up the extended price, but what if we want to just include the ones where the extended price is less than 50? Now, you might think that you could just use where for that, like so. Where total extended price greater than 50, but this doesn't actually work. So you get an error invalid column name total extended price, and even if you were to say sum of extended price, this still doesn't work. And the reason is because this sum can't happen until after the rows are grouped. So first the group happens, and then you can look at the values that you've grouped by. So instead of using where, what we actually have to do is use having after the group by. Like so. And now this will work perfectly fine. So here are the ones with the extended price, sum of extended price greater than 50. Here are the ones with the sum less than 50. And then this will not work. So that doesn't work in having. It works in where, but it doesn't work in having. Now you can combine where and having as well. So for example, let's go and get rid of that for a second. And now if we wanted to include both the ones where the total extended price was less than 50 and where the repair number was equal to 1123 or something like that, we could say where FK repair number say between 1121 and 1124 having sum of extended price greater than or less than 50. So these are first filtering the rows based on repair number in this range, then grouping the remaining rows by repair number, aggregating the extended price, using halving to select only the rows where the aggregate price is less than 50, and then ordering the results by repair number. Show the part number and total quantity for all parts in the PO line item table whose total quantity is 1 gross 144 or less. Display results in ascending order by total quantity. So let's look at the PO line item table. And what the query is asking us to show is part number. So we have the FK part number and the total quantity. So we want to group by each part. So one row per each part, which we can determine with the part number. So group by part number and then sum the quantity. And then use halving to compare the total quantity to 144. Selecting 1 gross or less, so that's less than or equal to 144. So let's go back up to our previous query. And get rid of the where clause. And if we wanted to just include the ones where the total extended price was less than that, we just saw how to do that. But now let's do the sum of the quantity field. That's total quantity. And then we could select the ones where the total quantity was less than 4 by saying halving sum of quantity less than 4, or less than or equal to 3. For each row, show the repair number and total extended price from the repair line item table. So let's look at that one. So for each repair, so you want to group by the repair number so that you get 1 row per repair. And you want to show the repair number, so that's going to be in your select clause. And then total extended price. So you're going to sum the extended price column. And then display the results as text and avoid this warning message. Warning: null value is eliminated by an aggregate or other set operation. So let's look at the customer table. So that has some nulls in it. And then let's say we were going to group by state and sum the apartment numbers. It's kind of a crazy query to do, but we can do it. So let's select the state province and the sum of apartment number. And then this is going to be from customer. And we're going to group by state province. And then if we run this query, operand data type varchar is invalid for sum operator. So that's because this is actually represented as text. So let's convert it to a number. So convert, and then as numeric, and we need a closing paren here. Oh, so convert numeric, comma, apartment number. There we go. Okay, so let's try this now. So you'll see I have nulls here. And I also have, if I go to the messages, I have warning, null value is eliminated by an aggregate or other set operation. So I want to get rid of this warning. And there are a couple of different ways to do it. So one way of doing it is instead of just returning the apartment number, I can return is null apartment number, comma, 0. So this has got to be the same type as this. So this is text, so this has to be text as well. And this basically says if the apartment number is not null, go ahead and return it. Otherwise, use this default value instead. So it's going to add the apartment numbers, and then for everybody who doesn't have one specified, it's going to end up adding 0. So let's go ahead and try that. So give me a curly under this from here, so let's see what we get. Oh, I forgot a parenthesis. There we go. Oh, and this is supposed to be character string literal. There, now it should work. Okay. Right, so now all the columns before where I was adding null and getting a null result, now I'm adding 0, and I don't have that message anymore. So that's the first way to do it. And then the second way to do it is instead of using is null here, I can use where to select only the rows where apartment is not null. So it should be the same results because I've gotten rid of the ones where it was 0. But the difference here is you'll notice I didn't get the rows back where it's 0 at all because I filtered out those rows. So a little different result, but basically either way is avoiding the error message. This says for each repair, so make sure that you actually have each repair in your return results. So name, address, and city, state, zip, last 3 concatenated into a single line for all customers who do not live in an apartment. Sort by customer number. So given what we've just done here, it should be pretty easy to pull those customers out. And formatting the name, address, and city, state, zip code it should be the same as you did for the previous assignment, so you should be able to do that one with no problem. So question 10 asks you to create a table in the database. And we don't have write access to fire it up, so we have to switch to a different database that we do have write access to, and there's one called CIS 275 Sandbox that we have permission on. And this statement, use CIS 275 Sandbox, is transact SQL to switch databases. So this line will do it for you and should already be in the SQL file that you're starting with. So the create table looks like this. You say create table, and then you give it a name. So I'm just going to do I'll do a faculty table. And then you start with an open paren, and then you have a list of all of the fields in the table. So the first thing I want to do is create a primary key for my table. And I'm going to create a surrogate key, which is automatically created and generated. And so I'm going to call this faculty ID, and the type is going to be numeric, make it 18 characters wide with nothing after the decimal point, as primary key, and then I can specify identity 1, 1. There we go. Okay, so this is saying create a field named faculty ID which holds a number. It's the primary key, and it's automatically generated starting at 1 and then incrementing 1 for each value that's added. And then let's have a first name field. which is going to be a character string, and we'll make that 50 characters long. And then we want to have a last name field, and I'm going to make this a varchar just so it's a different type. So character is going to be fixed at 50 wide, varchar is going to be just wide enough to hold the last name, and that's 3 columns. So I can go ahead and close off this parenthesis here and put a semicolon. So let's go to the CIS 275 sandbox, and we'll look at the tables. And we have some MD ones laying around. And what I want you to do here is whenever you create a table in the sandbox, instead of just putting the name of the table, go ahead and put your initials in front of it. So MG_faculty, and that will help to avoid 2 students who are trying to create the same table name, and will also make it easier to go in and see which one is which. So just take your first initial and last initial, put an underscore in front of the table name, and you'll be good to go. So I'm going to go ahead and execute that. Oh, and I have to use 275 sandbox as well. And it completed successfully. So now if I go to tables, right click, and hit refresh, you see that there's an MG faculty table here. And under columns, it's got a primary key, which is numeric 18,0, not null. First name, which is 50 characters, null is allowed. And last name is varchar 50, null is allowed. And you can use other data types as well. You could put dates in here. You could have Boolean values. You could have other kinds of numerics. Oh, so when you're done with it, at the very bottom of your file, it's a good idea to go ahead and add, after use 275 sandbox, add drop table MG faculty. And the reason for that is, let me show you what happens if I run this script again without doing that. So this time it says there's already an object named MG faculty in the database. So it doesn't create it, it leaves it there. But if I execute this at the end of my SQL file, now if I refresh, the MG table is gone. So I can rerun this whole file as many times as I want without getting an error. So be sure any tables that you create, be sure to add a drop table statement at the bottom that cleans up after yourself. Not strictly necessary, but it will save some errors when you're testing. So this one asks you to look at your work from last week's lab, where you did the customer purchasing items from a grocery store chain. Find 2 of the entities in the entity relationship diagram you put together, and go ahead and create them as actual tables in the database. And the specifics will depend on how you did your layout. Make sure that at least one of them has a primary key, and then later on you're going to be asked to add a secondary key constraint. So write 2 separate SQL statements to insert data into the table that you just created. So I'm going to go ahead and I'll do the MG table again. Okay. So I have MG faculty, first name, last name, faculty ID. And then to go ahead and insert rows into the database, use the SQL insert statement. So insert into MG faculty values, and then you give 1 value for each column here. So the faculty ID will be, say, 101, and then the first name will be Mark, second name will be Goodman, and that's one row. We'll put David Schooler in there. And that's 2 rows. Put Dan Doherty in there. Okay. Oh, yeah, so I'm getting red curlies under here because these have to be character string literals. Sorry. So there we go. Okay, so now it should work. So I'm going to go ahead and execute these 3 statements. So an explicit value for the identity column in table MG faculty can only be specified when a column list is used and identity insert is on. So basically it wants to, since this is a surrogate key, it wants to automatically generate the value. So instead of specifying it, it's just going to auto number starting from 1. So this first column gets supplied by SQL, and then these columns are the values I supply. So let's try it now. Okay, so I've added 3 rows. Let's go ahead and do a quick select star from MG faculty just to make sure they're actually there. Boom. Okay, so I've added 3 rows to my database. So select all rows from the new table you've just created and then use cast and convert to display them nicely. So you should be able to do that. Write a SQL statement to add a column called last modified date to your table. So this should be of data type date time. Ensure that the column may not contain nulls and provide a default value for the rows that have this value missing. So you want to use the alter column command here. Alter table MG faculty. I want to add, and let's call last modified, which is a date time, not null. And then to specify the default, we want, just put a date today, or just want to put a date. And then I want to specify a default value, and I'm just going to use the current date, which I can get with getDate, like so. So this getDate, if you go ahead and say like select getDate just as a standalone statement, it returns the current date. And so this is going to be the default value. Whenever I create the record, it's going to get stamped with whatever the current date is. So let's go ahead and try this. And it completed successfully. So let's refresh this table. Right click and refresh. And now we have a last modified date, which is of type datetime, not null. So write the SQL statement to create the other table from the one-to-n relationship above. So for example, if you did purchase, then or purchase line item or something like that, the purchase line item would be on the n side of a one-to-n relationship, because one customer can have many purchases, purchase line items, but each purchase line item only has one customer. So in the previous one, you created one side of the relationship. Here you're going to create the foreign key side of the relationship, and then you're going to use a foreign key constraint on it. So I'm going to go ahead and create a foreign key constraint on my MG faculty table. So my primary key here is faculty ID. So I'm going to create another table that uses the faculty ID as a foreign key. So like a class assignment. So one faculty member can have many class assignments. Each class assignment only has one faculty member. So create table MG under assignment. And then open paren, and then a list of the columns I want it to have. And I'll have an assignment ID, which is numeric and primary key, identity. I'm going to start this one at 100 and go up by 1 each time. And then in order to create the foreign key, I first have to create the field to hold the value of the foreign key, and then I have to add the constraint that ties it to the primary key in the other table. So this is going to be FK faculty ID, and the type of this field has to exactly match the type of the primary key, which was numeric 18. I can double check that. Yep, numeric 18. And then I'm going to add a foreign key, and it's in the MG faculty table named faculty ID. A little problem there. Foreign key references. MG faculty ID. Okay, so now this worked. Let's go ahead and execute it. And it completed successfully. So I'm going to go back to my tables, and I'm going to refresh. And here's my faculty table, here's my assignments table. So the gold key is the primary key, silver key is the foreign key, and it references this column in the faculty table. So now, let me go ahead and drop the table. I'm going to drop the MG faculty table. Oh, and I can't, right? Because it's referenced in the foreign key constraint. So I have a second table that references it, so now I'm not allowed to drop it. In order to drop it, I first have to drop table MG assignment, and that completed. Also kills the constraints, and that completed. So now I've dropped both tables. So you see they're both gone. Now if I go back up to here, and I execute this query to create the table, and then I insert the rows, and let's go ahead and look at the values. So here are the current faculty, and now add the last modified date, and look at the faculty again. So now it has the last modified date that's been initialized to the current time and date. Create the assignment table. And now let's play with that a little bit. So I'm going to try to create a record in the assignment that matches a record in the faculty table. So insert into MG assignment values, and then this is first column is a primary key, so I don't supply it. Second column is going to be the faculty ID, so I'll pick one that's valid. I'll say 3, and if I execute that, here's my new record. But now watch what happens if I try insert into MG assignment values 4. So this is a faculty ID for which there is no faculty member. Now I get insert statement conflicted with the foreign key constraint. Conflict occurred in database C75 sandbox, table MG faculty, column faculty ID. So basically, all of this means that there is no faculty member with faculty ID 4. If I go ahead and and then have insert a new faculty member. Yeah, I did the same thing I did before. I should have used single quotes here. So let me use single quotes. Okay, now run the insert. And now I have a problem because I have to include a last modified date. So let me go ahead and add 26215. And now it works. So now if I show the data in the MG faculty table, I have 4 rows, faculty ID 4, and now I should be able to execute this statement without an error. And it seems to have worked. So I have 2 faculty assignments. So that's how the foreign key constraint works. You have to have the primary key in the other table, and then it's going to validate my data every time I try to do an insert or every time I try to drop a record. So that's it for this lab. Good luck, and let me know if you have any questions.